Okay, so another integral that we will do using integration by parts, tan inverse of x. In ln x, while integrating ln x, हमने यही काम किया था. We assumed that, and it is a fact, it is being multiplied by 1. So this is also being multiplied by 1. So if I ever want to integrate tan inverse of x, I can say that it is being multiplied by 1. In writing this complete integration by parts. Okay, how do I integrate tan inverse of x? What do I take as u? Tan inverse of x. And what do I take as v dash? 1. So what will be my u dash? What is the derivative of tan inverse of x? It is provided in MF19. 1 upon 1 plus x square. And what is our v in this case? X. So now if I wanted to integrate tan inverse of x, I'm doing it using integration by parts. U into v. U is tan inverse of x into v is x minus integral of v into u dash x into 1 upon 1 plus x square.
X square से x cancel.
Nahin, it's being added, it cannot cancel out. So how does this all simplify? नहीं, पहले let's see, do we need to apply? इसको मैं अगर simplify करूँ, so x upon
1 plus x square.
Now how do I intend to integrate this? In the denominator I have 1 plus x square. What is the derivative of 1 plus x square?
Derivative should be 2x.
2x. I already have an x in the numerator. Very good. I just want to multiply this by 2. If I will multiply this by 2, I will also have to by half, so that I do not end up changing anything. Now I get this in the form, the function is in the denominator and the derivative is in the numerator. So how will this integrate? This will be x tan inverse of x minus half of ln 1 plus x square plus c. So if you ever want to integrate tan inverse of x, this is what you will end up at.